Good afternoon and welcome to the closed loop configurations webinar. My name is Ramon Fardonk. I'm an applications engineer for Fortress Power, located in San Juan, Puerto Rico. Uh, Today's webinar is scheduled to last about 1 hour. So at the end, if you have any questions, feel free to write them down, and I'll do my best to see if I can answer the questions. Okay. So why closed loop configurations? I will have to start saying that uh, when we started with the renewable energy systems, uh, one of the concerns that we had at the beginning was uh, that our batteries were being handled in the proper way, uh, and because that's one of the I will say the one of the most sensitive components of the system, and and I will have to say is that most of the times used to be one of the most expensive components as well. Okay, so being able to take care of the batteries in the right way will ensure us that the system will last for for the time expected. Plus, you will be complying with the warranties that were being offered by the different manufacturers. So, for the system owner, as well as the installer, as well as the manufacturer, uh, being able to make sure that the batteries were being treated in the right way will depend on the way that the system has been configured, the parameters that are required to handle the batteries in the right way during the charging process or even during the discharge process. Okay, so uh, having to program the system became a matter of understanding by the either the owner of the system if he was doing a DIY, or the installer if he was installing a system that he will later on have to make sure that the system was working properly and that the batteries were configured. Okay, so programming the system with the right parameters that the manufacturer came up with and suggested for the system became one of the most important parts of the actual installation. Let me see if I can switch this. So today we will be going over what is it that closed loop has to do with. Okay, and I try to make a very short presentation with different topics. One of the first things that I would like to mention is about definitions. Okay, sometimes people and it's not a bad thing. They don't even know the terms that we are getting to getting used to here during the commissioning of the system or even during the usage of the systems. Okay, we will be going through different terminology that is very popular and very common when we are talking about our batteries interacting with our system, or for us as the users to be able to understand the different concepts that are involved when we have a battery connected to our system. We will go over the basic components of a system that are required to be able to do closed loop. Okay, and I will explain what is it that closed loop deals with. The scope of what is it that we will be able to understand or will be able to do when we have a system in closed loop configuration. Okay, we will go a little bit over the benefits that this provides when you have a system in closed loop. I will show you some wiring diagrams on how to establish closed loop between our batteries and the different inverters, so you will understand the requirements in terms of that configuration. And then we will go over the questions and answers session. Let's start with definitions. In order to understand what closed loop is, I will have to go first over the concept of having an open loop system. The open loop system is where we used to have two different components interacting with each other, but all the configuration that had to occur between, in this case, our batteries and the inverter or the charge controllers responsible for charging the batteries, uh, the programming had to be done manually. Okay, so once those parameters are provided by the manufacturer of the battery, were configured or programmed into the system, those parameters were, static, and if the conditions of the operation of the system change during the day, those parameters will not be adjusted, because that was just the way it worked. Okay, and that's how we started at the beginning, having open loop system. If we go back to the lead acid batteries, there was simply no way of communicating those batteries with the system, other than knowing to which parameters the system was configured. Okay, and we will go over what are those parameters. Okay, so in order to go to understand a closed loop, we have to understand where we come from, which was an open loop system where the configuration was done completely manually. Okay, and it was a static configuration. So when we move into an open loop system, okay, now there's a communication going on between the battery and the inverter, or the overall system uh, that is taking care of the batteries. Okay, so uh, and we will go into what information is being exchanged between the batteries. Of course, this closed loop system didn't exist when we had lead acid batteries, because there was no component in the battery side to be able to talk to the system. So when we started with the lithium batteries, as most of them have, will have a battery management system component inside the battery. The battery was, became intelligent enough to send information from the showing the status of the battery to the rest of the system, and that's what it's called closed loop system. Now there's a conversation going on between the battery and the system. Okay, so when we go into closed loop, okay, we will have to get used to some other terms that are related to the concept. Okay, and I mean, this may be, popular or known to many people, but as of today, there's still people that don't know, or don't, never heard about some of these terms. The first one, and it's very important, is it's called state of charge percent. Okay, the state of charge, it's the point where the battery has gone in terms of the charge level. Okay, and when we have a closed loop system, that information is automatically sent by the BMS, the battery management system, into the inverter, so the inverter will know what's going to happen next. Okay, uh, well, it is an important, you know uh, term or value, because that's what is going to tell us as the user and the owner of the system if the battery, at which point the battery is okay, if it has been depleted or it has been charged, or at which point of the charging process the battery currently is. So state of charge is one of the terms and most important terms. Okay. uh, State of health. Okay, as we have batteries, lithium batteries, and all kind of batteries. As we start using our batteries will degrade. I mean, will start losing health throughout time, because either whether if you use it or if you don't, the battery will still lose health. Okay, and the BMS is able to understand the way the battery it's being charged or discharged, and how efficient this charging process has become, or the lack of efficiency that will determine that the battery is it's failing in terms of health. And at some point in time throughout the years, the battery will come to a point where is that it's not good anymore. Okay, so state of health is it's a value that is sent from the battery into the inverter. And if we have monitoring applications, we will be able to where is our battery, based on the time that has gone. Okay. uh, so next we have maximum charge amps and rate. This is the unit of measures of amount of energy that is being sent to the battery for charging purposes. Okay, and most of the batteries, if not all the batteries, are very sensitive in terms of the amount of energy being sent. The manufacturer will provide this value, and it's as important and many others, because it will reflect the way that we have been treating our batteries in terms of charging you know them throughout the time. uh, Using the wrong value in amps used to be one of the major problems before, when we used to have for example lead acid battery banks, or when we were using open loop configuration, because the as I mentioned, the parameter had to be entered manually. Okay, and any mistake done or misinterpretation of the information provided by the manufacturer will eventually damage the battery, because it's being charged in the wrong way. Okay. The maximum charge voltage is another term that we have to get used to, because it's the way at which voltage is our battery is going to be charged. And depending on the configuration of the battery, these batteries may go, for example, from 48 volts all the way up to 53, 54 volts. Okay, and when we were using it or doing it in open loop mode, specifying the wrong voltage will eventually damage as well the battery. Okay, so now remember that these values are being sent by the battery, or specifically the BMS, to the inverter, which is at the end of the day the responsible of doing the charging of the battery. Okay, okay. And last but not least, there are two concepts or terms that have to be in our minds. Is that the communication that it's going on between the batteries and or the battery bank, okay, and the inverter, or the maybe the whole system. It's based on. I will have to say that it's based on two specific languages, if I may. Uh, the first one is Modbus, okay, and I will go into a little bit more detail about Modbus, and the other one is CAN bus. Okay, so when we acquire or buy a new battery, okay, one of the things that we have to ask is if I'm going to communicate my battery with an inverter, which protocol is the one that this battery talks to, okay, or uses to communicate, okay. And at the beginning, most of the batteries were doing it using Modbus, but throughout the time, Modbus, it's been around quite a while, since the 70s, but now then it changed to CAN bus, and most of the inverters manufacturers or the batteries are moving towards CAN bus, okay. So let's talk about Modbus. Okay, Modbus, as I mentioned, is kind of like a language. Okay, that was invented back by 1979, and it's a way of communicating information electronically. Okay, through a cable. Most of the time, you will see that our batteries are well, the batteries are being communicated using a standard Cat5 cable, which is a normal cable coming, the ones that we use with our PCs connected to a router in our homes, okay, or in the office. So Modbus is basically a protocol of exchanging information, and it was used in the beginnings at implementing uh, programmable logic controllers, or PLCs, in manufacturers, to send information on what was happening, what was being done in the production environment. Okay, and then we came up with a CAN bus. CAN bus came up back in the 80s, 1986, and it was first implemented uh, using in the cars, automotively. Uh, so if you any of you remember that every time we get uh, an engine light, check engine light in our cars, okay, there's a guy that comes and plugs in a tool into our cars, and basically what it's doing is reading the computer, okay, and extracting information from our cars. uh, that was done at the beginning with Modbus, but most of the cars lately, they use it's CAN bus, which is it's a protocol or language based on what used to be Modbus before, okay, and it's been enhanced. It's been done, in many ways, but the origin of the protocol, it used to be Modbus as well. Okay, it's more specialized. It's more uh, broad in terms of the information that can be exchanged, and the amount of information that can be exchanged at some point in time simultaneously. So let's talk about basic components. Okay, so when we have our batteries, we bought uh, our lithium batteries, and I'm talking about in terms of general batteries. Of course, this is a Fortress battery, but to understand the concept, first we have to understand that uh, when we buy a battery, there's a the board that I mentioned, which is called battery management system. It's a computer board inserted inside the battery. Okay, and the first batteries used to have this board. Okay, and it was called just the BMS. Okay, uh, and I will make I will tell you the difference, because BMS at the beginning, although its function was to control and manage and monitor the way the battery was being charged or discharged, the way the battery was being treated. The BMS, it's a piece of a technology that is provided by the manufacturer to make sure that the conditions of the way the battery should be treated are being met. Okay, so the manufacturer went into the BMS and inserted or programmed all the information, all the parameters that I just mentioned are programmed into the BMS. Okay, and the BMS will eventually send that information to the inverter and make sure that the battery is treated properly. Okay, so when the first lithium batteries came out, okay, they of course they had a BMS, but the BMS was pretty much used to make sure that the battery was being charged or discharged properly, but on top of that, it would allow to communicate between establish a communication between multiple batteries. That, I mean, if you were the case that you had two or three or four or five batteries, the BMSs in the different batteries will communicate using the Cat5 cable, okay, between batteries, and information was being shared between the batteries and not necessarily at that point in time with any inverter. So the BMSs were communicating just to make sure that they were, let will say, sharing the responsibility of charging and discharging the batteries in in the right way, or in the same amount at the same time. Okay, but the communication was just between batteries, not with the inverters. And the board that was being used, the BMS that was being used, will look something like this. Uh, there were some harnesses connected to the actual battery, measuring the voltage, the amps that were being sent to the battery, temperature, and things like that. Uh, but they were only communicating between batteries, not with the inverter. I will have to say that that used to be called just the BMS. Okay, later on, with new technology, the manufacturers came up with what it's called a smart BMS. And the smart BMS not only does what the BMS used to do, but now the smart BMS it's able to gather all that information from all the other batteries working together, okay, and send that information to an inverter. Our batteries, they all have smart BMSs, so not only they will be able to gather the information and work together as a team, but they will gather the information and send it to the inverter. Okay, so in terms of who received the information that the smart BMS is receiving, okay, uh, we have the inverters. Uh, Most of the inverters will have, as you see, one of those ports, RJ45 ports, which are the connectors that Cat5 cables are used. Okay, and that port will be identified within the inverter. And I said most of the inverters use the same way of doing it. Okay, of course, our inverter, the NV 8, 10, or 12 versions have this port, so we will send, connect a cable between the battery and the inverter. They are, of course, our batteries are being used with many other inverters, and I have to say it because, for example, the other connection that we have, it's kind of like a connection port, okay, with multiple pins available. This one is actually used with the Schneider electric inverters, and that's the way of doing it. And it will not use the uh, the RJ45 connector. You probably have to cut the cable, the Cat5 cable, and look for the corresponding pins that are required to be able to establish a Modbus communication or a CAN communication. Okay, a CAN bus communication. Okay, so that's on the inverter side. Okay, and then of course the interface cable, which is, looks at the end, looks like this. Okay, this is just an example of this is a regular cable, Cat5 cable being built. That's why you see the pins, and I use this one because the pins have a very important role in terms of which pins are going to be used to be able to establish the communication. Okay, and that's why I like this picture, because we will see later on how they have to interact with the different systems, inverters coming from our batteries, to be able to achieve Modbus communication, or the concept which is closed loop communications. Okay, so when we achieve closed loop, okay, there are things that we will be able to do. Okay, so this only applies to lithium batteries. I mean, the, there wasn't closed loop communication with lead acid batteries before. Okay, and as I mentioned, there are two different type of BMSs. The BMS, uh, just the BMS, not without the smart word. Okay, uh, yes, it will communicate information, but as I said, it will only happen between batteries, not with the inverter. The smart BMS version is the one that does what the BMS does, plus being able to communicate with the inverters. Okay. The communication is optimized and suited to specific battery manufacturer, of course, because as I mentioned, when the BMS was built and integrated into the battery, the manufacturer, okay, recorded or program or specified the parameters under which their battery, and in this case our batteries as well, are going to be allowed to be charged and discharged. Okay, so that information is right there. Basically, we're making sure that the equipment, the inverter, will comply with these parameters, and we will be in a better position of handling warranties in case of if it's required, just to make sure. The BMS also stores information, historical information on how the battery was treated in terms of charge and discharge. So when we go into trying to troubleshoot a battery, we will be able to connect into the BMS and pull up the information that was stored, and we will find out that if the battery. So that's part of the responsibility of the BMS as well. uh, is limited to a specific number of batteries connected. Yes, because when you are going out for a battery, lithium battery, one of the things most of the manufacturers will say is that you can have up to a specific amount of number of batteries interconnected between each other. Remember, I said that you can have two or more batteries. Okay, in our case, we have two specific models, which I will show you later on. But we can interconnect about I think it's 20 Evo Maxes together uh, in terms of communication. Okay, remember, we're talking about communicating batteries among each other, not necessarily connecting batteries in terms of power into the system. We could have more if we want, but to communicate them, uh, Evo Maxes, you can have 20, and Evo I'm sorry, E-flexes, we can have 30 batteries communicating between each other, and then from the first battery communicate to the inverter. Okay. Uh, in 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 previous configurations, where the systems were modular, meaning that we had an inverter, we have a charge controller, and we have many other equipments being part of a whole system, but they were all modular. Uh, when we were able to achieve closed loop communications, the information was being sent from the battery, or the BMS, the smart BMS, was being sent to the inverter. As we all know, the charge controllers, they play a very important role in the charging process of the battery, but as they were not, necessarily integrated into the system, okay, the closed loop communication will only provide information to the inverter, okay. So we will still have to do open loop communication, okay, or programming of the different parameters within the inverters, okay, within the inverters. So uh, when the new all-in-one systems, as our inverter, which is the Envy in the three versions, 8, 10, or 12 kilowatts, uh, the charge controllers are part of the whole system. And when closed loop communication is achieved, okay, all the information is being sent to the whole system. So now not only the inverter, but the charge controllers will know as well what are the parameters that are required to be able to to charge, or up to which point I can discharge this battery. So all-in-one system, one of the benefits that it has is that the information being exchanged between the batteries and the system will apply to all the components of the system. It will not happen, as I mentioned, with the modular systems, because they're just not part of it. Okay. As I mentioned, in only one configuration, all the information is being uh, shared between all the different components. And by the way, this information, once shared between the battery and the BMS and the system, it's not is you won't be able to change it. Okay, you can't go into the system unless you tell the system that you will not be using closed loop communications, that you would rather do it in open loop. But then you will have to specify the different values, uh, and program the whole thing by yourself. And we're back to square one. We as a manufacturer can't guarantee that the parameters were entered properly, and the batteries will be in charge of the whole process if you go back into open loop configuration. So yes, you still have the choice of selecting closed loop or open loop, but now you understand what are the risks not doing it in closed loop configuration. So let's talk about benefits. Okay. As I mentioned already, okay, parameters are sent automatically from the battery, from the BMS into the whole system. You don't have to take care of that. Of course, it is good you understand what is being exchanged and sent from the battery into the system. So like as I mentioned at the beginning, about volts, about amps, about temperature, about state of charge, state of health. But that information is being sent automatically from the battery into the whole system. Okay. uh, the charger will never exceed those parameters. Okay, that's the whole thing about closed loop. You will never overcharge your batteries, which will eventually damage your battery, which is one of the most expensive part of the components of the system, and the most one of the, if not the most delicate. The batteries are the ones that we really have to take good care of them. Okay, so the inverter will never do anything against that will supersede the information that was exchanged by the battery. Uh, One of the components that is important when we select batteries are that they are certified. In this case, I'm talking about specifically. There are some other certification, of course, but I chose this one because it's the most general one that will include all other certification, and that's called UL 9540 certification, which means that when you have an inverter uh, connected to a battery, and those two components are exchanging information, that they are operating as one. Okay, there's a process where the system has to be certified, which means basically that the operation is safe, that they know how to work together. Okay, and we are certifying that all the required testing has been done between the batteries and the inverter working together. Okay. When the battery is completely discharged, okay, the inverter basically will receive information from the battery saying and specifying the parameters that will mark the limits, will tell the limits of the charging process in terms of voltage and amps. As the battery starts getting charged, okay, of course there's no need to keep sending large amounts of amps or a higher voltage, because the battery is getting, very close to the full state of charge. So batteries don't like to be rushed in the way they're being charged. Okay, of course, when the battery it's pretty much empty, you can send a lot of a really large amount of amps, as long as it is within the limits, uh, to charge the battery. But when you get to that point, which is mostly after 60, 70% or 80% of the state of charge of the battery, you will see that the inverter starts kind of like controlling the amount of energy being sent to the battery, and it will go down very to a very minimum amount, because meaning that the battery is pretty much completely full. uh, who sends that information? Is the BMS. The BMS will start adjusting the numbers automatically through the CAN bus communication, okay, or the closed loop communication, because the CAN bus is a protocol, is a language being spoken, but the information will travel from the battery, and it is the battery the ones who's going to tell the inverter that take it easy. I'm getting to a point where I'm already full, and no, there's no need to rush it. Okay. And this is one of the most popular examples. We see, and we have a lot of customers that will most of the time will have more than just one battery. Okay, and each battery has a capacity, based on the model. Okay, and when the correct sizing and design of a system it's done, okay, one of the things that has to be determined is how much battery do we need to be able to run our loads for a certain amount of time, and that's the amps hour capacity of the battery. So if you decide that it was decided that you need 4 or 5 batteries in case of it's an eFlex 5.4, and you need 20 amps hour, 20 kilowatt uh, battery bank, you will probably have to have 4 of them in parallel communication. Parallel for in terms of power consumption, yes, but also in parallel in terms of communication. So as I mentioned before, the 4 batteries, which now they total 20 amps, uh, that information will be shared between all the batteries connected into the closed loop. And if we have 4, now the master battery will know that the whole bank is made out of 20 kilowatts, and that's the number in terms of amps hour, okay, that which will be about 400 kilo amps hour being sent to the inverter. So he knows that now the inverter will know that it's how much capacity it's available in the battery bank. Okay, and that's was gathered by the BMSs and sent, summarized, and and added up and sent to the inverter. Okay, and as I mentioned, making sure that the parameters that are provided to the inverter will comply with the manufacturer's requirement. Okay, remember, this is about making sure that the battery is being used the right way during charging and during discharging of the battery. Okay, so those parameters, they're now part of the BMS. They were inserted there by the manufacturer, and those parameters are being sent to the whole system, to the inverter and the charge controllers. So uh, most of the systems will not allow for these parameters to be changed, as I mentioned before. But yes, I mean, it's all about programming. Most of the inverters will allow you to override or supersede uh, the the uh, the configuration choice, but it will be at the level of deciding if you want to behave in closed loop communication or in open loop communication. If you are in open loop communication, you are taking responsibility that the parameters that are being provided they will comply with the manufacturer's requirement. If you choose closed loop communications, of course, those parameters are being sent to the inverters, and it's going to be a lot more easier when you get to this point that you want to request a warranty for a battery. If you say, my battery has been in closed loop communication since the beginning. Okay, so I'm ruling out that it was mistreated in terms of the way that the parameters were specified. Okay, but if you chose closed loop, you will not be able to change those values. You will be able to see them, you will be able to monitor them, but you will not be able to change them. You will have to change the inverter's configuration into open loop, so and then you will have full access to those parameters, but you better understand what's going on and what are the parameters that have to be provided. Okay, so now let's talk about different diagrams and why is this important. Okay, different inverters uh, chose different pins in terms of, as I mentioned before, we're using a Cat 5 cable. Okay, and some inverters use some pins depending on the battery, and other inverters simply use different protocols, or they decide that they want to use other pins. And this information in terms of depending on which inverter you are using, and which of our batteries you're using, either if it's the eVolt or the eFlex, they both have their own requirements. Okay, and you have to make sure that these are the cables that you're going to be using to communicate uh, from the master battery into the inverter will have to comply with this configuration. All this information is available in our website. When you go into fortresspower.com, you go into the support section, and you will see inverter guides. Okay, and in that inverter guide, you will see these configurations. Okay, so you have to make sure that the cable coming out of the master battery, okay, will end up in the inverter using those specified pins, which have are color coded. Okay, uh, one of the things that when we communicate our batteries with the different inverters is that we have to tell the battery which inverter we're using, because the conversation that is going to happen between our batteries and the inverter may change. Okay, and that's a fact. It may be different, so we have to tell the batteries that we are connecting to a specific inverter. Okay, when we use our when you use if you decide to use our inverter, so which is the NV in any of the sizes 8, 10, or 12. Okay, the communication, of course, it's optimized, it's done by the manufacturer. Any problem that may arrive between the exchange of information with the battery and the inverter, it's provided completely by us. We take care of our inverter, we take care of our batteries, and all the, the 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 software, the communications protocol, and everything is responsibility of Fortress. So you will not see the typical scenario when a problem arises that sometimes you say no, that's a battery problem, you have to go to Fortress, or no, that's an inverter problem because now you're using a solar. Not That's not going to happen when we have you have an NV communicating, or have our batteries communicating with the NV. We will deal with the whole thing, and the communication it's built by us and only us. That's the left side of the this slide. On the right side, okay, is the example that I mentioned that, and I have to say it because it's the truth. It's out there. Uh, Schneider does not communicate closed loop with directly into the inverter. That will not happen that way. You have to go to a different piece of equipment, which there are two different versions of it. Okay, and one is the inside home, and the other is the inside facility. Okay, and they both have different ways, different means of connecting the cable that comes out of the battery into the system. It will not go directly into the inverter. It will have to go first into the inside home or inside facility. And you see the combination of pins that will have to be used, and to which pins on the inside side those pins will have to be provided. Okay, and there's a whole procedure on once the connection is it's done between the batteries and the inverters, uh, in terms of configuration that have to occur within the inverter. Okay, and that's all documented in our inverter guides available in our website. So depending on the inverter that you decide to use with our batteries, just make sure you download the inverter guide. As I said, the pin configuration is provided there, all the different steps, step by step, very graphical, very self-explanatory, and you will be able to create a closed loop from our batteries into the inverters. Okay. The next slide that I would like to show you is let me change here. It's this one. Okay. I've been talking about and a lot about having multiple batteries. Okay. And one of the things that we have to make sure, and remember, this is all because we want to be able to create a closed loop communication between our battery bank and our inverter. And as I mentioned, the all the batteries have to be interconnected among each other, so the different BMSs from the different batteries will be talking to each other, and I'm trying to show here how this interconnection occurs. The first one will be with the Evo Max. There are ports dedicated to make sure that this communication occurs. Okay, and this is called basically a daisy chain communication. We go from the very last battery into the next one and to the next one, and then at the end we send the cable that is going to communicate with the inverter. But the most important part of this is that we have to specify at the battery, and I'm trying to highlight here that the eVolt has an LCD screen, and as part of the installation of the battery, one of the things that have to be done is that you have to assign a number, a specific and unique number to each battery. And okay, so that's the battery ID. And when we have, as you will see, we have the battery ID number one. It's shown as the one that is communicating to the inverter, and you can see that using the Cat5, the yellow Cat5, it's using the two ports on the right side of the battery. And when we decide to go to from the battery number one into the inverter, we're using the other tools, uh, ports that are available. And you will see that there's one that will specify RS485, that's Modbus, okay? And there's another port that will say CAN bus, the one on the left of the black cable, because as I mentioned, our batteries, we are able to provide both protocols, RSA 485, which is a Modbus, and CAN bus as well. Okay, on the right side of the slide, then we have the eFlex. Okay, and the eFlex, okay, uh, there are some other considerations that you have to take care of for the Evo, that you have to specify which battery is the last one of the daisy chain. You do that, but that's all part of the inverter guide. That you will see it there. Okay, uh, and in the right side we have the eFlex 5.4. Okay, and we see as well that we are going from one battery into another using the yellow cable, and then from the last battery in the battery bank, where we decided to go into the inverter. The only difference here is that eFlexes, they have to, and it's provided with the battery. You have to include a little connector, which is called the pinout converter. Okay, that basically what it does is it tells the three batteries in this example that where does it start, where does it stop in terms of the last battery, and from that pinout converter to the inverter, some reconfiguration of the pins is going on, which is not important at this moment. But the thing is that connector has to be there to comply with the proper installation and configuration of the closed loop connection to the system. Okay, and of course, you don't see a display, an LCD display in the in the eFlexes, but that's part of the functionality of the eFlex. Once you start the eFlex, you turn on every single eFlex, they will talk to each other, and they will assume a battery number automatically. You don't have to specify like in the evos that you have to go to display and say this is battery 1, 2, and 3. This will happen. That will happen automatically when you're using eFlexes. So that leaves us with to which inverter we are communicating. Okay, and there's a procedure that you have to connect to the battery bank, and you will have to specify the protocol ID as the same way when we specified it in the evols. Okay, every inverter has a number. Okay, and you have to do the same thing. It's just that you don't have a display to do it. There's a procedure to connect to the battery bank and say, oh, we are communicating with an Envy, we're communicating with a Schneider, we're communicating with a Solar. Okay, it's done inside the battery, and it's done once, and that's it. It doesn't matter if you turn off the batteries later on. That information is going to be stored, and it will become permanent as part of the configuration of the batteries. Okay, so this is my last slide in terms of achieving closed loop. Okay, it's a matter of communicating the batteries with inverters, and as I mentioned, Fortress Batteries has one of the and this is a fact. It's not an opinion. It's a fact. One of the best BMSs out there available, and it sends a lot of information to the inverter. Plus, in addition, it really reads what is going on and happening with the batteries, and being sent to the inverters, to the different inverters. It's just that you know the advantage that when you have Fortress batteries and a Fortress inverter, this communication is taken care by one single manufacturer, which is us. Okay, so I hope I was able to send the message of in a very not complex way of on how to achieve close communications with our batteries, and what is the purpose of close communications, and batteries are getting very sophisticated as the technology is of the BMSs start improving, and a lot of things are being able to be done from the battery and the different inverters. I'm opening up for questions now. If you have any questions, feel free to submit the questions, and I'll just try to answer that. I see a question here. Please share the slides and the presentation. Thanks. I will make the presentation available. So I think it's getting recorded, so it will also be available at some point. Okay. Well, if there's no any other question, yeah. Oh, yes, sure. Here's my contact information, so you can reach me there. There's my email, my phone number, uh, and the technical support email where you can contact us. I'm saying thank you in Spanish, muchas gracias, uh, and I hope you enjoy the uh, the presentation. A list of closed loop inverters. Uh, I mean, most of the inverters in the industry are pretty much getting to that point. Not all of them have, of course, but if you go with the most popular ones in the market, of course, MB is already there, but most of them are already complying with the closed loop communication. Okay, so I will be more concerned if the battery, you won't have that problem because both our batteries are made to comply with closed loop communications, but Envy complies with that as well. Okay, so you can use our batteries with most of the leading brands in the market, of course. I'm not seeing more questions. So if that will be all, thank you very much. I hope you took some information, good information from the presentation, and hopefully we will continue providing more general concepts of the technology. Okay, so uh, the the different topics that are we're coming out continuously to share with you guys, and how do we comply with those concepts with our technology. Okay, so good afternoon to everybody. Thanks for being part of this presentation, and we will see you on the next presentation as well.